As our functions get more complicated, our algebra may be more work, but we find the output for a corresponding input in exactly the same way. So we have an x squared plus 1 for our function. So if we wanted to find f of 0, then we would just take 0 squared, substituting 0 in for x, and then we have our plus 1, which would be 0 plus 1, or 1. And we can find f of 3 the same way. We substitute 3 in for x to get 3 squared plus 1. 3 squared is 9. We add in our 1, we get an answer of 10. If we want to know what f of x plus 1 would be for this function, we have to remember that we're substituting in x plus 1 for x, and in this case we're squaring that. So we're going to square whatever's being substituted in for x, which is x plus 1, and then we have our plus 1 from the end of the expression. Now, when we multiply x plus 1 squared, we have to remember that we need to use FOIL, or polynomial multiplication, in order to multiply that out. So that's really x plus 1 times x plus 1 plus 1, right? That's what something squared means. You multiply that thing by itself, and that's what we've done. X plus 1 times x plus 1 plus 1, giving us x squared plus 2x plus 1. And then we have our plus 1 from the end here. So altogether we get x squared plus 2x plus 2. And if we want to see what f of 2x plus 1 would be, well, this is our input, 2x plus 1, so we substitute that for x everywhere x occurs in the rule. So this would be 2x plus 1 squared plus 1, which is 2x plus 1 times 2x plus 1 plus 1, which is 4x squared. When we multiply the first terms, the outer terms give us 2x and the inner terms give us 2x, so together that gives us 4x. And when we multiply the last terms, we get a plus 1, and then we have this plus 1, giving us altogether 4x squared plus 4x plus 2.